These notes are going to deal with equations that pertain to ratios, proportions, and percents, and you've dealt with a lot of this through your pre-algebra days in 6th and 7th grade, but there are some newer spins on things that are more Algebra 1 related. So some of this you will find as a review, others of it you will find as brand new material. The first thing we want to do are define some old words that you are already familiar with. The first one is ratio, and ratios use division to compare two quantities. And remember that ratios can be written in one of three ways. Right? They can be written as words 7 to 5 with the word 2, T-O. They can be written with a colon, 7:5, or they can be written as a fraction, 7/5. Right? Those are the three different ways, and they all stand for a ratio. For this purpose, you'll want to use the fraction one as the most productive one through your equation. Right? Then the word proportion. And a proportion is an equation, so that's why it fits in this chapter, that states that two ratios are equal. And you should recall that in order to solve a proportion, we use what are known as cross products, cross multiplication. And I'll remind you of what that looks like when we get to the first examples. All right, so these notes are going to be separated into three separate sections. The first section is going to be the ratio and proportion section. And I'm going to provide you with some examples with the work attached to it in hopes that when you get to class and do these examples in class that you'll have a better understanding of what to do with them. Okay. So the first one is your basic proportion. If I have x over 72 equals 3 over 8, right? In order to solve, you're going to use cross products, and we multiply diagonally. I like to take the one that has the variable in it first, so that it always puts my variable on the left. So if I take x times 8, that is 8x, put your equal sign, and then go the other direction. And 72 times 3 is going to give you 216. And at this point, you're at a one-step equation. So we divide by 8, and the value of x that is missing is 27. All right, so this should be something that you're very familiar with from your past experiences. But now let's take it a notch up. Right? Here's what your ones for algebra look like. Y plus 8 over 21 equals y over 9. Right, so you've got two variables in different locations, but you're still going to use cross products. The big thing to watch out for is when you take 9 times y plus 8, that you are taking 9 parentheses y plus 8. Right, so you have to make sure that that two-term item from the top is in parentheses and that all of that is being multiplied by 9. Then that equals the other direction. 21 times y is 21y. And in order to solve this, you do have to distribute first. So you have 9y plus 72 equals 21y. Okay, and you should recognize you have variables on both sides, so we want to move the smaller one. That means we need to subtract 9y from both sides. We now have 72 equals 12y. Okay, and then you want to divide by 12 on both sides. Right, to give you y equals 6. Sorry. So the final answer is y equals 6. Right, so you're solving it once you get past the cross multiplication the same way we've been doing it. Right, it's just you have to get past that hurdle from the beginning. Right, now let's take it another notch and look at some other variations of the proportions. Okay. They don't always give them to you set up. You may have to set them up yourself. So if I give you this analogy, x is to 6 as 0.8 is to 1.5. Right? With this statement, you can write your own proportion and then solve it yourself. So x is to 6 would be written as x over 6. Put your equals, that's where the as, and then 0.8 is to 1.5. Right? And there's becomes your two ratios now that are your true proportion. So you're cross multiplying. Okay, so you would end up with 1.5x equals 4.8, divide by 1.5, and the value of x equals 3.2. Remember, this is the one instance where you can give me a decimal because you started with decimals in the original problem. Okay. The next type that still involves these ratios gives you a word problem of sorts. If a map has a scale of 1 centimeter equals 15 kilometers, find the actual distance if two places are 7 centimeters apart on the map. Right, so with this one, the scale becomes part of your proportion. It's the first ratio that you use. Right? Because we have centimeters and kilometers, you can actually set up your proportion in a consistent way. So we're going to do 1 centimeter over 15 kilometers on the left ratio. For the right ratio, you're going to use the 7 centimeters and put it over top of x because we're missing the real amount of kilometers. And then you're going to proceed to solve. So after cross multiplying, you end up with x equals 105 kilometers. Right, and think realistically about this. If it's on a map and it's 7 centimeters apart, then in the real world it should be a bigger distance. Right, if you get a smaller number, then something should cross your mind as to it not being correct. Okay, and the last one of these before we go into the second section, okay, is also a word problem. Okay, if a secretary can type 32 words in 60 seconds, how many words can she type in 150 seconds? And again, a proportion is what we would use to help us solve this in the quickest way possible. All right, so we're dealing with words and seconds, so we're going to put 32 words in 60 seconds. Stay consistent, put your words on top. We don't know how many words, that's where our x goes, and we do know she's typing in 150 seconds. So now you're ready to cross multiply, right? And that would give you 60x equals 4,800. Divide by 60. And you should be figuring out that x equals 80. Now don't stop at just 80. I need to know what the number 80 is referring to. Is it referring to the words or the seconds? And in this case, it's the amount of words. All right, so she can type 80 words in those 150 seconds. All right, so make sure that you have a unit behind those word problems that require them. Okay. All right, the second part of these notes deal with the percent proportion. And hopefully you remember the formula that went along with that. If not, I'll bring it back to your memory and you should jog or remind yourself what you're doing. If you remember, percent over 100 equals is over of. Or for the is, that's your part. And for the of, that's your whole. Okay, if you remember this, then this is the entire proportion we're going to use to help us set up what we're doing next. And I'm going to give you 3 examples to show you where the x can appear in 3 different places. Right, so if we have the example 21 is 35% of what number? Okay, you have the percentage. Percentages always go over 100, so 35 over 100 is your first ratio. The next statement says 21 is, so that is part is your 21, and that goes on top. It said of what number? That's the number we don't know. So here's your proportion set up. When you cross multiply, you end up with 35x equals 2100. So divide by 35, and you should find out that the missing value of x is 60. There are no units in this problem, so we don't have to worry about a unit for our answer. All right, the second one would be what number is 46% of 150? Again, we have our percentage, so we put 46 over 100. This time the question is asking what is, so our is part is missing, and then it says of 150. So the 150 goes on the bottom in the of position. Right? So we cross multiply, we have 100x equals 6,900. Divide by 100, and we end up with x equals 69. And once again, there are no units in this problem, so we don't have to worry about units in our answer. right? And the third one that deals with this proportion, obviously the only place the x hasn't been yet is in the percent spot. So what percent of 250 is 85? Okay, when we set it up, we don't know the percent, so our x goes over the 100. And then it says of 250, so 250 goes in the of spot, and then is 85, so 85 goes in the is spot. All right, go ahead and cross multiply, and you're going to end up with 250x equals 8,500. Divide by 250, and we should find out that x equals 34. Now, because we were looking for the percent in this case, you can't just leave me with 34. You physically have to put the percent sign to get your full credit on that problem, right? Because that is what we were missing. Okay, and then the last section that we have to deal with, right, is translating. And we've already done a little bit on translating, but it's going to sneak back in here for equations. And you're going to have to not only translate them, but also solve them. So in order to solve them successfully, you've got to translate them successfully. Right? So I'm only going to show you 2 of these, and then, like I said, we'll practice a lot more with these in class. Right? And you'll get a little better feel for it if you're a little rusty. Right? So for the first one, the sum of 14 and twice y is the same as 78. All right, so to translate it first, sum means to add, so put your plus sign. We're adding 14, so there's your 14, and twice y. If you do something twice, you do it 2 times. So that's 2 times y. Is the same as is your equal sign, and then 78 goes on the other side. Okay, and then from there you would solve it. I'm not so much concerned about your ability to solve it at this point as your ability to translate it. So if you wish to solve that one, you can, but I'm going to focus more on the translating aspect. All right, and then the second and last one that we will deal with, the difference of 22 and the quotient of a number m and 4 is 54. Okay, so take this in smaller chunks so that you can get this right. Difference means to subtract, so we're going to subtract 22 and the rest of the stuff. So 22 minus, right? Then we have to deal with quotient, which is division. So we're going to divide a number m, so that's our m, that's first, and then 4. So 4 is going to go second. Remember that whatever comes before the word and is the numerator, whatever comes after the word and is the denominator. And then all of that is or equals 54. And from there you can solve it if you wish to. Right, so we will keep practicing with these in class. These are just extra topics that involve equations that you have to be able to solve and handle. Right, so we'll make sure that you're pretty good at those before we move on to test day.